Hi guys, so this is lesson 2 on vertical projectile motion. So namhlanje let us talk about graphs, how to draw graphs. Graphs ke la kwi vertical projectile motion. 3 kenzeka kuthiwe draw i-position time graph. I-position time graph ukusayi displacement time graph. So it is displacement versus time. Kenzeka kuthiwe draw i-velocity time graph, velocity versus time. Kenzeka futhi kuthiwe draw acceleration versus time graphs. So what is important here is to understand ukuthi adwetshwa kanjani lama graphs. Okay, sizokhuluma ngezinto ezibalekile la ezincane nje bafundi bami. Let me use a different pen. Let's say la we have an object that is projected vertically upward. Sizokhuluma nge-position time graph. This object is projected vertically upward from a certain height. Let's say this height is 30 meters high. The height of this building is 30 meters, and we are projecting an object from the edge of this roof. Izohamba it. This will be the shape of the motion of the object that is projected from the top of this building. So at this point, it hits the ground. Yeah. So last time we said at this point, its displacement is equals to 0. Let us see what is senze today. Its displacement of the ball at this point will always be equals to 0. But let's say siyaqhamuka instruction. They say draw a position time graph. Draw a position time graph and use the ground as 0 reference. If they say use the ground as 0 reference, that means x-axis akho, or you will use your x-axis to represent any ground. Our ground will be represented by x-axis. X-axis. Now x-axis where we have time. Always time is an independent variable. So our y-axis will be here, its displacement. So your graph will look like this. So this is the height where the ball was projected. This is the height. So this is how our graph will be like if they say use the ground as 0 reference. Bengashintsha futhi mfundi, but I use the point of launch as 0 reference. So ikhumbula ngithi scenario yethu ukuthi bekanjani ibhola bel projected from this height. Angithi i-height ibiyubani ibiyu-30 meters, and this is our ground. Now sebethi use the point of launch as 0 reference. As 0 reference. So, our x-axis now will be, our x-axis will pass through the point of launch. Our x-axis will pass through the point of launch. Upper x-axis it naka. We are born time. Also, upper y-axis it naka. This is position in meters. Digraph it. As easy as like that. So, height yethu, height building ebi 30 meters. Ubonile lapha before i-height siyibhalile laphaya u-30. Now uyabona ukuthi i-height yethu isikuphi manje, isi-below our x-axis, below our time axis. Isila, anything below our time axis is negative, so it's gonna be negative 30. So the height, we are measuring the height from the top of the building to the ground is about 80. Uma sidweba and use the ground as zero reference, we are measuring the height from the ground to the top of a building and becomes positive 30. So this is how our graph looks like. This is a position time graph for the ball that is vertically thrown or projected vertically upward. So let us talk about now an object that is dropped or thrown vertically downward. Lama object la le ama graph ale object as well. This is the height of a building. A ball is projected or dropped from this point and goes downward like this. As you can see, this is our ground. Okay. Now instruction is to draw a position time graph and use the ground as zero reference. Lana is zero reference. Ground. Zero reference. What does it mean? If they say use the ground as zero reference, kushuta x-axis to agopi I represent any e ground. Where is the ground? This is the ground. So our x-axis will go like this. Not forgetting that the height of the building is still that height of 30 meters above the ground. So this is our x-axis and this will be our y-axis, which is our displacement. So here we have our 30 here, the height of the building, the initial position of the ball. So this is our graph. So now we have delta y in meters, which is our position, and t in seconds. So the value of t here is the time it took the ball to hit the ground from the point it was projected until it struck the ground. So this is the velocity, the position time graph of an object that is thrown or dropped vertically downward. So let us talk about the same graph, but now we're gonna use the point of launch as zero reference. An object thrown or dropped like this, and this will be our ground. Now the instruction change and say use the point of launch as zero reference. Use the point of launch as zero reference. So our graph will go like this. Our t-axis just go past the point of launch, and this gonna be our y-axis, which is our position in meters. So the height of the building measured from the top to bottom will be negative 30. Ground, zero reference. Point of launch as zero reference. So now let us move to velocity time graph. Velocity versus time graph. Let us do a recap on what we did last time. We said velocity at this point, if it was thrown vertically upward at 10 meters per second, this side it's gonna be negative 10 meters per second. At the same point, if the initial velocity is 10, when the ball comes back downward, this side it's gonna be negative 10. At maximum height, v is equals to 0. This is how we said velocity changes with time. This side, we said if it is 10 going up, it's gonna be 7 until it reaches 0. Then from that, -7, -10, -11, -12, -13 until it strikes the ground at -14. So in this case, we were taking downward as negative. So let us continue with that direction. We are taking downward as negative. Let us draw the velocity time graph. For this motion, the ball is projected vertically upward. So when the velocity was 10, t was equals to 0. Let us assume and say at this point, maximum height, t is equals to 2 seconds. So it's gonna be t equals to 4 seconds at this point, because the time taken for the ball to move from the point of launch to maximum would be equal to the time taken from the maximum height to back to the point of launch. So let us say the whole motion lasted about 7 seconds. So our final velocity is 14 at 7 seconds. So when we plot a graph, I always encourage learners to use this method, which is table method. When t equals to 0, this point, velocity was 10. When t equals to 2 seconds, velocity was 0, maximum height. When t equals to 4 seconds, velocity equals to -10. When t equals to 7 seconds, velocity equals to -14. So this is how we plot our graph. The important thing here is to plot the first point and the last point. Let me use the same color, the red one. The first point and the last point, and the time for the last point. The first point is 0 is to 10, which is here. The last point is 7 is to -14, which is here. And you construct the two. Then at this point, let us go back to our table. When the graph touches the x-axis or the t-axis, t is equals to 2. And we also have 4 is to -10. So this is our meters per second, and that is our t. In upward as negative and down as positive. So here we're gonna have, if we are changing directions now, this is gonna be negative. Our initial velocity is negative, and this is gonna be positive, because we are taking downward as positive. This is our Cartesian plane, where we have v in meters per second and t in seconds. Our initial velocity now gonna be -10. +10, +14. So our initial velocity now is here as -10, and we have the point of 2 is to 0, which is right here. 2 is to 0. We have a point 4 is to 10. This is 4, and this is 10 somewhere here, and we have 7 is to 14. So it is right here. So your graph will be like this. So this is for the ball that is projected vertically upward. So let us talk now about an object that is dropped. Or let us start by talking about an object that is projected vertically downward. So if it is projected vertically downward or thrown vertically downward, so it has been given an initial velocity. Let us say the initial velocity here is 5 meters per second. That is our initial velocity. So the time taken for the ball to hit the ground is, let us say it is 2 seconds. Using the table method, t initially time is 0 and the initial velocity is 5. Finally, time is 2 and the final velocity, let us say the final velocity is 7 meters per second. So it's gonna be 7. If you notice here, our initial velocity is positive and our final velocity is positive. That means we are taking downward as positive because the initial velocity is going downward and also the final velocity is going down. That is why our variables here are positive. So this is how our graph will be like. Velocity in meters per second and t in seconds. Our initial velocity is 5. Let's say 5 is here. Our final velocity is 7 and t at that point is 2. So our graph will go like this. If you notice here, our graph does not pass the time axis or the x-axis because we don't have the maximum height. So this is our graph if we take downward as positive. If we take downward as negative, so it's gonna be negative here, negative here, negative here, and negative here. So our graph will be like this. This is our initial velocity -5. This is our final velocity -7. So we draw like this. This is our velocity time graph. You can see this line is straight. Perfect. So let us talk now about an object that is dropped. When an object is dropped, that means the initial velocity is 0. So here we have 0. If an object is dropped or released from a stationary object, the initial velocity is 0. So when it hits the ground, it's gonna have a certain value. Let us say in this case it is -5. Why -5? I'm taking downward as negative. So our initial velocity when t equals to 0 is 0. When t equals to 2 is -5. I am taking downward as negative. So our initial velocity is here, 0 is to 0. Our final velocity, our final point 2 is to -5 right here. So our graph will go like this. We are taking downward as negative. But if we were to take up downward as positive, so it's gonna be positive here, positive here. So this is 5. Our first point 0 is to 0. Second point 2 is to 5. Right here. This is our graph. Okay, Bafun, let us now talk about acceleration time graph. So acceleration due to gravity is constant throughout the motion. Aishinji doesn't change. Let us say we are taking downward as negative. If we are taking downward as negative, so our acceleration is gonna be -9.8 meters per second squared. because we are taking downward as negative. Acceleration due to gravity is always going downward. So it doesn't change. If an object, or if we are asked to draw an acceleration time graph, this is t, and this is acceleration in meters per second squared. This is our negative 9.8. Let's say the motion lasted for 2 seconds. So our graph will move from this point straight to 2 seconds. This is your acceleration time graph. But if we are taking now down as positive, so our A gonna be 9.8 meters per second squared. So this is here, and I'm gonna draw for this one, which is 9.8, lasted for 2 seconds. So our graph gonna be like this, and this is for this. Should use a different color. This is for this. Yeah, this is our acceleration time graph. Straight by weight. Why it is straight? Because acceleration is constant. Don't forget to hit the like button and subscribe.